PowerShell Remoting is one of these features that everybody uses, but very few people actually fully understand or configure it properly. In this video, I'll show you to get started with PowerShell over HTTP. And we will set it up the right way. We will start by understanding what is actually happening under the hood. We will dissect which protocols are used by PowerShell Remoting. We will dive directly into configuring PowerShell Remoting for your environment. Together, we will go through configuring PowerShell Remoting using the GUI, scripts, or even GPOs. We'll show you how you can manage single machine, 10 or hundreds of them. At the end of this video, you're gonna have a clean and reliable understanding how PowerShell/WinRM works over HTTP. Hey guys, I'm Stefan and welcome to my basement. I'm an 8-time former Microsoft PowerShell MVP. I've been automating Windows and Linux environment for more than a decade, and I've spoken in multiple PowerShell user group and conference across Europe. And on top of that, I will show you how to use PowerShell Remoting in a workgroup and how to use it in an Active Directory domain. And yes, I also cover the most common errors that every engineer will do when working with PowerShell Remoting, so that you don't have to Google these errors afterwards. All right, so let's start. Let me explain some of the basics. PowerShell Remoting is built on WS Management, commonly known as WS-MAN, which stands for Web Service Manager. It is a remoting protocol created by Microsoft, which uses SOAP, a firewall-friendly protocol, over HTTP or HTTPS to transfer messages over the network. PowerShell Remoting works on port 5985 for HTTP and 5986 for HTTPS. These ports are standard defaults. They can be changed, but this is not the topic of today. The simplest form of PowerShell Remoting is the one called built-in remoting. Built-in remoting is the remoting component present in many official out-of-the-box commandlets shipped by Microsoft. It allows you to do remoting using a parameter called computer name. Built-in remoting will work instantaneously out of the box without you having to configure anything. Well, it depends on your network environment, of course, but theoretically, it should work out of the box. In this example here, you can see that I'm using get hotfix in order to connect to a remote machine, using the minus computer name parameter in order to connect to a remote host and list all the installed Windows updates. Although we do remoting administration tasks, this is actually not PowerShell Remoting, as here we're using another protocol called RPC, or Remote Procedural Call, as its underlying protocol. Also, built-in remoting is actually present in a very small and very limited amount of commandlets. And on top of that, it depends which version of PowerShell you're using, specifically PowerShell Core and Windows PowerShell. The list of available commandlets are not the same. But to make things more easy for you guys, I've put a link in the description down below, which will contain the list of all the built-in commandlets that come with built-in remoting support. But I will invite you to click on this link after you finish watching this video. PowerShell Remoting is disabled by default on Windows client operating systems, such as Windows 10 and Windows 11. But did you know that PowerShell Remoting is configured and enabled by default on Windows Server operating systems? That's pretty cool, right? It is super easy to enable. In order to enable PowerShell Remoting, you have to use one single commandlet, and it's called Enable-PS-Remoting. It is super easy to enable PowerShell Remoting on your machine, and you can do that directly in PowerShell. Open a command prompt and write Enable-PS-Remoting and press Enter. There you have it. That was quite easy, right? Before we look at what Enable-PS-Remoting actually did under the hood, let's take a minute and look at this most common problem that people face when they use Enable-PS-Remoting for the first time. Sometimes we can have the following error message: WinRM firewall exception, blah, blah, blah. And don't blah, blah, blah. Read the error message carefully, because the answer is actually in the error message. It actually says the firewall exception could not be created. What does it mean? How do we solve this? Well, actually, the answer to this question is actually, again, in the error message. It actually says it right here. change the network connection to either domain or private. This is pretty easy to fix, you will see. We can fix it in two different ways. There is the good way and the not so good way. The good way would be to use the parameter skip network profile check on the Enable-PS Remoting commandlet when you execute it. The better way, though, would be to go and switch the connection type to either private or domain, because this has a direct impact on Enable-PS Remoting not being able to create the firewall exception that it needs. And a quick note before we dive in. If you like this type of content, consider liking and subscribing this video. It really helps to send the message that you actually appreciate what I'm doing and will probably push me to do even more. So now let's go back to what Enable-PS Remoting actually did on our computer. If we have a closer look, we can see it did the following three things. One, it created a firewall exception. In this case, we can see it opened a rule for the port 5985. The second part is about the WinRM service. It started the service and set its startup type to automatic. And the third part is the HTTP listener, which it went and it created for us in the background. Now, configuring this for a single machine is nice, but it won't scale very well, specifically if you do not have another type of remoting capability available to you. If you work in an enterprise, chances are big that you are working within an Active Directory domain. And when we talk about Active Directory domain, we very often talk about, yes, you're right, GPOs. So let's enable PowerShell Remoting via GPO. Let's first create an empty GPO. Then we're going to go and open the group policy editor. In this new group policy, we want to configure two things. One, the WinRM service. We want to allow remote server management through WinRM to be enabled. This will enable the HTTP listener for all the machines that are affected by this group policy. It will create a listener that will listen on port 5985. We can specify an IP address that we would like to listen to, or if we open and we want to listen to every IP address, we just put a star in that box. After that, we want to configure the WinRM service itself. We want to enable it and set it to automatic. Like that, at every reboot, it will be started and available to be used. Last but not least, Windows Firewall. I would like to create a new firewall exception. And for the HTTP listener, which is the one we actually configured right now, there is a predefined rule that we can simply enable. So for HTTPS listeners, you will see there's no existing default rule that we can simply enable. For that, we will need to create it ourselves. Now that we have seen how to configure PowerShell Remoting on a single machine and how we can potentially configure PowerShell Remoting on multiple machines, let's go ahead and try things a little bit out. Hey guys, I'm back again. Hey, if you have not subscribed yet, you still have a chance to do it now. I'm not forcing you, but I would really appreciate it. Hey, Stefan. What are you doing? Oh, you want a break? Yeah. Yes, I agree. You actually deserve to take a break. I'm gonna explain how to use the remoting commandlet, then afterwards you take over and you explain them how easy it is to configure an HTTPS PowerShell Remoting listener, and on top of that you take over the explanation of the OpenSSH. Okay? Sounds like a plan. Let's do it. The first command I would like to have a look at is Invoke-Command. Here we use the parameter name, computer name, with the server that we want to connect to, DC001. We give him a script block and a credential and we can connect. We can reuse the same code, simply change the computer name and we will be able to target another server using the same credentials and the same script block. Second commandlet is Enter-PSSession. Here, this allows actually to create a session and to save it in a variable for future reuse. In this case here now, we can see that I'm recalling again Invoke-Command. I'm removing the credential parameter. I am passing the variable session to the PSSession parameter. Now we can create a second session to another computer, in this case DC001. We can see now we have two different sessions that are open. Now, where it becomes to be really interesting is that we can add those sessions into an array. And so we can see we have the two sessions in that current variable. Both of them are currently open. It is possible now to execute a script block, here in this case get hotfix, and we give it the array of sessions. What will happen here is that we can see it will go ahead and execute get hotfix on both of the servers at the same time, and we get the data back at the same time. That is pretty cool, right? And last but not least, Enter-PSSession. You will see here we have our open session, and I'm currently connected on DC001. I can enter in the PSSession using Enter-PSSession, and if we check the computer name, it is SRV001. At the very left, we have an indicator in which session we currently in. Here we can see we're currently connected on SRV001. We can check for data using any command that we like, and once we're done, we simply exit the session using Enter-PSSession. And once you're done, you can close and remove all the sessions using Remove-PSSession. Okay, looks like I'm done here. Stefan, I give the stage back to you. I think you wanted to show something about HTTPS, but I believe you wanted to talk about trusted host before that. I'll show you how easy it is to configure PowerShell using HTTPS to address one caveat that exists with PowerShell Remoting. Don't worry, nothing too big specifically that I will show you how to fix this issue so that you won't face this problem in the future. And this problem is called serialization. It's actually not a problem per se, but you have to know the process so that you can use it correctly. So let me explain what I mean by that. PowerShell Remoting will rely on WSMan, and WSMan implements the SOAP protocol. And SOAP tells us that when a message is transferred over the network, it must be converted to XML. This facilitates the transport of the message from point A to point B. This conversion from a PowerShell object to the XML structure is called serialization. The raw command is transformed in XML. The XML is sent over the network, and when it arrives on the destination, there's the inverse process that gets executed, and it's called deserialization. It's the matter of converting the XML data structure back into a PowerShell object. All of that is done for us by PowerShell itself. For us, under the hood, nothing to do. We can just use it. If you're more curious, you can have a look after this video at the Cmdlets import CleXML or export CleXML. So this is the magic behind PowerShell Remoting, or WSMan if you will. This ease of use comes with a drawback. It is not possible to transfer complex data structure over the network. So let me explain what I mean by that. In this example right here, we're fetching the audio service locally on this machine, and we're just displaying the message. And so we can see we went and we fetched the status of the service locally on this machine. And when we look at the status, we can see it's stopped. Now, if we go and inspect that variable using getMember, we can see that the type of object that we have is of type system service. That is very important. We can see right here that no serialization took place. That means we have access to a bunch of methods such as start, refresh, etc. So now, if we go and execute the same command remotely on our distance session using Invoke-Command, what will happen is that under the hood, our object, our command, will be converted in an XML structure. This XML structure will be sent over the network to a remote machine, and it will be deserialized on the remote machine, and the command will get executed there. Command will be executed, and then it will be serialized again and sent back over to the network to our original host. Over there, we can cache this value and we save it in a variable. Now, if we look closer at the contents of that variable, we can see that, for example, if we try to stop it, it will not work. And this is the drawback of serialization. So why is that? If we take a closer look at the contents of this variable, we can see that we are missing those methods that we saw before, like stop, start, refresh, etc., and many more. And so if we go have a look at the type of object that we receive back, we can see that the object is now of type deserialized.system.service. And so this is what I mean with we will lose some functionality. We will lose methods that are attached to our object if we use remoting and if we are not smart about how we write the code that we use for remoting. And so there's a solution for this. And I just said it before. Let's be smart by writing this code that we're going to be using in the remoting session. So how we do that? So it's very simple. Instead of wanting to stop the service locally on our machine, let's stop it and do all the actions we want to do with that remote service remotely in our remote session. And actually, this makes sense. But sometimes it did not. So do all the things you need to do on the remote machine, on the remote service, in that remote script block. Write all your code for that remote session in that remote script block. And then execute it and send only the results back. And this is serialization. Inside an Active Directory domain, you can trust the identity of the servers to which you try to establish a connection, because there's an authority, the Active Directory domain, which is going to validate the identity of the servers of its Active Directory domain using a protocol called Kerberos. This basically means that PowerShell Remoting will allow you to access this server as soon as Kerberos allows it. If you try to reach a server that is located outside of your Active Directory domain, PowerShell Remoting won't allow that by default because it has no way of trusting the identity of the server that you are trying to reach. For that reason, PowerShell Remoting cannot use Kerberos even if you are located in an Active Directory domain. In that particular case, it will fall back from Kerberos to NTLM. And so for these computers that are located outside of your Active Directory domain, PowerShell has a mechanism called trusted host. It is somewhat an extra layer of security. You can specify servers in a specific list. In a nutshell, if you try to connect to a remote machine located outside of your Active Directory domain, PowerShell will first check if that server is part of the trusted host list. If it can find the IP address in that list, it is all good. It will let you go ahead and connect remotely to that system, but it will use the NTLM protocol. Now, on the opposite, if the server is not listed in that trusted host list, PowerShell will not allow you to connect to that remote machine. I want to show you first that I actually have connectivity to this client. The next logical step now would be to enable PowerShell Remoting on this freshly installed machine. For that, we simply call enable PS Remoting using -force and skip network profile check. Once that is done, we go back to our server and we try to invoke the command to this specific host with using the IP address and the pre-recorded credentials. So we can see here, again, we should not blah, 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 the error message, because it is explained in the error message what the problem is. So all we have to do is read it and take action on it. It basically says that here, the Windows client cannot process this request. Default authentication may be used with an IP address under the following conditions. The transport is HTTPS, or the server is located in the trusted host list. It also mentions at the very end that these servers might not be authenticated. What it means by that is that even if those servers are located in your trusted host list, it might not mean that these servers are really trustworthy. So the different ways to add servers in the trusted host list, the one that I use the most is using setItem and the wsman drive. You basically use setItem, you point it to the path, wsman localhost client trusted host, and you add the value of the IP address to which you want to connect to. You can see that after that, the connection actually works. To remove or to clear completely all the items from the trusted host list, the only thing we need to do is call clear item and give him the path and press enter. With all of this fresh knowledge about PowerShell remoting and HTTP, you probably want to answer the question, hey, is PowerShell remoting over HTTP actually secure? Why do we actually have PowerShell remoting over HTTPS? Well, I'm answering all of these questions right here.